Terrific. So I just want to welcome you to this talk, which is Objects as Software. This is Zach Hoken-Smith. He's the director of the RepRap Research Foundation. He's the creator of the Sanguino, which is a derivative of the Arduino. He recently wrote all the software behind the Thingiverse, where you can share digital designs. And he is, of course, a founding member of New York City Resistor, which I'm a member of, and we call him Sir Awesome.
I paid her to say that. Okay, well, thank everybody for coming. I'm really excited to talk to a captive audience. This is going to be fun, especially about something that I really love. So, which is digital fabrication. To get started, a little bit about myself. Like Max said, I like to start lots of new things, so I'm always like making some new thing and probably leaving something else unfinished, but I'm sure that's a common problem here. I started the RepRap Research Foundation, which is a not-for-profit that is designed to help do research and support the open source RepRap project, which is a 3D printer that makes copies of itself. Along the way, we needed a more powerful microprocessor, so I was like, well, I'll take Arduino and I'll throw in a bigger chip, and the Sanguino was born. And likewise with Thingiverse.com, we have all these designs for digital objects, and we really have no good place to share them. So I was like, well, I'll make Thingiverse and have a place for all my friends to upload their digital designs and have a place for other people to download designs and make them. And NYC Resistor is a place where I learn, share, and make. It's a nice little hackerspace in downtown Brooklyn. And if you want to get a hold of me, there's my email. I get way too much email because I always put it up and give it to lots of people, so I'll try and respond. So first, a disclaimer. I really love this stuff, and I play around with it a lot. And today, what I'd like to present to you is my dream for the future. There's no guarantees in life, and I'm certainly not psychic, so who knows what will happen until it actually happens. However, this dream that I'm going to talk about is shared by many people, and these are hardworking, smart people, and I think that together we will achieve it, so keep that in mind. So the core topic of the talk today is digital fabrication. And I'm not really going to go into the technical details of this because it's all over the internet. If you want to learn how stepper drivers work or control boards or G-codes or any of the like awesome nitty-gritty like super nerd cool stuff, the best place is the internet. What I want to talk about is the why and the passion of digital fabrication. Like, why am I here today, and why are there so many people that spend hours working and tinkering on these machines? So if you're not familiar with digital fabrication, it's basically computerized manufacturing processes. So machines like CNC machines, laser cutters, all sorts of machines that make physical objects but are controlled by computers are digital fabrication machines. It's all about taking the human out of the actual loop of producing things. I think it's going to change the world, but the revolution is not going to be televised. It's hard to put a time frame on it, but why not? 10 years. In 10 years, the revolution will be downloaded. You'll either design your own stuff and then make it with your machines, or you're going to download someone else's design and then make that. Most likely it'll be a little bit of both. Who here, just raise your hand if you wrote Firefox. Nobody? Not even a patch? But who here has written a little script to do something that, you know, fixes a tiny little problem you have? Probably quite a few of us, you know? Little like glue, Perl script, something like that. So in the future, I imagine it'll be a little bit of the same thing. So you might download a cool open source project that it's like a toaster or something. But if a little plastic cap falls off on your car's radiator or, some sort of fluid tank, then you make a custom one and use it, and life goes on. So someday, you'll have a machine that will make you anything you want. Yes, I'm talking about the Star Trek replicator. No, it won't be perfect at the beginning, but by the very of a machine that builds parts, you will have the tools to upgrade it yourself. You'll be able to bootstrap yourself into better and more advanced electronics. I call this the automation age. Throughout the course of human history, we like to classify the nature of our technology into the materials and things that define this age. We've had the Stone Age, the Bronze Age, the Industrial Age, the Space Age, the Information Age, and now we're going to have an age of automation where you can design something and then a robot will go out and do it. Obviously, this age will be marked by automation of physical processes, as well as the distribution of that technology to your average human. The distribution is the crucial part, because without giving it into the hands of every person that needs it, then it's just closed off and walled off, and it's inaccessible. The Stone Age wouldn't have been called the Stone Age if there was only a small group of humans who had access to stone technology. It's about getting this technology out to everybody that wants to be a part of it. You might also be able to call it the robotics age, but I think that might come after the automation age, when people are using these machines to build robots, Jetson style. But I lied. It's actually already here. A huge amount of the things that you use in your day-to-day life are actually made either wholly or in part by digital fabrication. CDs and DVDs that you use to install stuff are written and stamped by automated processes. The computers and electronics that I'm using to talk to you today are made with automated photo plotters, CNC machines, pick-and-place machines, and all sorts of these automated tools that build electronics. Same thing with just random consumer goods. Even the crappy plastic toys that you can get are usually made from molds that are cut by CNC machines. Books are another example. These things are made by automatic printing processes. And even something as simple as a shirt is made on highly automated machines. It's only really in the final step that humans sew them together into a shirt or a shoe or so forth. But it's not really here. I'd like to do a quick poll of the audience and do some stuff. How many of you have regular access to a CNC machine? That's a good amount. That makes me happy. How many have regular access, like you could go use a laser cutter within an hour? What about a 3D printer? Maybe 10 of you. What about a normal inkjet or laserjet printer? Yes, awesome. What about a computer? So basically, all of you in here have an 80s supercomputer and a printing press that would make Gutenberg's head explode. So to put this all in perspective, just a little mental exercise here. This computer, I think, has a 2 gigahertz dual-core processor in it, which I'm guessing probably translates into about 4 billion calculations a second. On a good day, I can probably do 2 calculations a second maximum. The computer does that many, many, many times faster, and it does it with 0 mistakes. It's not going to say 2 plus 2 is 5, but I might. The core lesson to come away is that when you automate these simple tasks, it drastically reduces errors, and it drastically increases the speed at which you can do them. To bring it back to digital fabrication, with a CNC machine, which is basically just a Dremel on a 3-axis, you could maybe do 1,000 millimeters a minute. A human on a milling machine might be able to do 100 millimeters a minute. So in this example, the CNC would be 10 times faster. It could run 24/7, no need to sleep, no need to eat, no need to drink. You'd have to, I guess you might have to feed it new material, but not the same. So essentially, digital fabrication is better, it's faster, and it's stronger. And so the thing here is that digital fabrication is just using very simple tools, a Dremel in the case of a CNC machine, a hot glue gun in the case of a 3D printer, a laser in the case of a laser cutter, and like a plasma torch in the case of a plasma cutting machine. They're controlled very precisely by computers. This is the real revolution, is adding that intelligent precision control that you can automate. The automation of simple tasks like this, like cutting a slot in this part or moving this glue gun and having it extrude at a constant rate. This automation of these simple tasks allows intelligent beings, us, to work at a higher level. My friend Archimedes said, "Give me a lever long enough and I shall move the world." We're extending that lever as we speak. There's a few metaphors that I found to be very useful when I think about this technology and when I talk to people about it. I come from a software background, so I grew up writing programs and code and stuff, which I think a lot of us share that background here. So I like to draw parallels between the world of software and the world of hardware. So the first one is your designs that you make. So like a design for a laser cut pump is the source code for that object. So if you change the digital design, you change the actual physical object. So you make a change to the design, you send it to your fabricator. In my example, I like to use a laser cutter. So send it to print, and it laser cuts it, and then you have a new object, but it's based on that original source code. An interesting thing about this is that it's possible to dynamically generate objects. Since it's just a digital file, you can very easily write a script that will generate that file that you can then, in turn, give to a friend. My friend Kelly wanted some display boxes, and she needed them to vary based on the different things she was going to put in the slots to display. So she wrote a Python script that generated a file, and then she could just easily generate a new display case that's completely customized to her needs. Also, as we all know, source code, digital files are very easy to share. The cost of bandwidth is pretty much free these days, especially with sites like Google Code, SourceForge, GitHub, and Thingiverse. You can just upload your files, and they'll send them out to other people for free. Finally, you should not make anything manually ever again. As programmers, we work at the level of source, and we have a compiler make the finished product. Hopefully, most of you don't code in hex. So why would you cut and drill holes into a board when you can have a machine do it for you? So the machine itself, I like to think of as the compiler. You have a machine, and you feed it some sort of digital representation of a real object, and then it transforms that design into a real physical object that you can hold, or a binary. So you have your source code, it takes it, crunches it down, and it turns it into something that will run on a computer, and then execute your instructions. To me, at least, it's essential that this part remains open. If you can't hack on the thing that makes your things, then you're going to be severely limited if you ever run up against something that you can't solve. So the ability of this thing to be hackable and for you to get in there and modify the inner workings is very crucial. And ideally, if your compiler can compile itself, then it allows you to self-upgrade and bootstrap yourself into the next generation of things. If we had to rewrite the compiler by hand every single time someone came out with an improvement to GCC, then there would be very few improvements to GCC. And finally, I like to think of the actual real physical things you can hold in your hand, like a bottle that holds this water, as the binaries. Sorry. This finished product doesn't contain any information on how to make it. All you can see is some general hints about how it was made. They had some sort of grooving thing come in and make the grooves on the mold somehow. But there's no specifications on, okay, well, we want the diameter of the thing to be this and the pitch on the threads to be that. You can find that by sort of reverse engineering and measuring it, but there's no real authoritative source on this itself. And also, it can only be shared the old-fashioned way. So if I give you this bottle, then, well, I don't have a bottle anymore. So whereas with your source, if I give you the design for the bottle, you can make your own bottle, and then I still have my bottle, and everybody wins. Finally, do you have the source for your CD player? Do you have the source for your computer, your mouse, your chair, all of these things? Essentially, every physical object we interact with in the real world is closed source because you don't have the design files that are needed to make more of these things. Sure, you can look at it and say, oh, well, that's how they did that. I can do that too. What I'm talking about here is people designing something, releasing the source code for that on the internet, and then you, with your machine, can download that source code and then make yourself another copy. And if, this camera doesn't work the way you like it, then theoretically, if you know enough about it, you can get in there, change the source, and then make yourself a better one. And if you're using an open source one, you release that on the interwebs, and then other people can benefit from that as well. So what are the implications of this? Well, first of all, robots are going to take over the world. It's just going to happen. I mean, they're just so cool, and there's so many obvious benefits that it's inevitable. But the thing is that it's up to us to ensure that it happens in a good way. One thing I'd like to say, if anybody ever tells you that technology is neither good nor bad, they're lying. All technology is created with a purposeful intent. AK-7s were made to kill cheaply. Some guy wasn't just like, oh, I'll just put this steel in a certain configuration and let's see what people do with it. So if you're making technology, examine the intent and why you're making this technology. With digital fabrication, we're building tools of creation. These things are explicitly designed to create and build new things, and which is one of the reasons why I feel it's a very beautiful technology. None of this stuff is designed to kill or maim or hurt. It's all about building things to help improve the lives of your friends, your family, and the rest of the humans around you. So, what happens when things go digital? Well, first of all, you can design something in place A, you can email it to place B, and then the person in place B can print it out. You can also do version control. So you can roll back to cut version 1.2 if version 1.3 isn't, it's leaky or something. Personally, I love version control. It's excellent, and I'm glad someone invented it. You can do easy worldwide collaboration. The RepRap project, which I'm totally obsessed with, is distributed across the globe. I'm in New York. The guy that started it is in the UK. There's a ton of people from Vienna, the Netherlands, New Zealand, Australia. I think we have pretty much someone from all of the major continents and probably every country. Not only that, but because you have the source code itself, you can make as many copies as you want, or at least as you can afford to make. I don't want to beat you over the head, but the idea is that you can work at a higher level of abstraction. That abstraction allows you to get more done in an easier way, much better than you can by hand. And you can scale. So here's an example of that: design in one place, build in another place. My friend Marius Kentel from MetaLab is really kicking some butt here. He designed this twisted star cylinder box, something you could just use to hold, jewelry or doodads or whatever. And he uploaded it to Thingiverse. And then a few days later, another guy by the name of Chris Palmer, goes by Knophead on the internet, built it with his RepRap machine. And so these two people are separated by, I'm not sure exactly far, but let's say 1,000 miles. And they were able to share this design. They're able to essentially share these physical goods without paying any sort of postage fees or anything like that. They just sent it over the internet, and then the other person had a machine, he hit print, walked away, probably had a tea break or something. He's from the UK, so. And then when he came back, he had this excellent little container, and I think he gave it to his wife for a birthday present, so, which is nice. Another cool thing is that with these machines, you can have infinite customization because it's all a digital design. Like, you feed the machine a design, it does it. It doesn't care what the design is. It doesn't say, oh man, there's too many circles in this guy, like, lay off. You can just, you can feed it whatever you want. So I'd like to show you an example that one of our friends, Oskay from Evil Mad Scientist, made. It's a snowflake generator. Let me see if I have it here. So this is just a little processing sketch, and it starts off with, oh no. Okay, yes, giant snowflakes. Okay, so it's pretty simple. If it works. All right, sorry about that. Let me try another one. Okay, so it starts out like this. And you just grab the things on here, and you can just control it to do like crazy things like that. And then when you're done, there's a save button on here. It's down on the bottom. You can't really see it. But this will write it to a vector-based file. And then you can send this to your laser cutter and have your own custom snowflake. And you can create 1 million individual snowflakes. So let's use our brains for a minute here. Imagine you're a manufacturer. You're a manufacturer that makes toy army men. You have to make 1 million of a model of a toy army man in order for the economies of scale to pick in and make it worthwhile to produce. Your constraints are that you have to make each soldier as a solid piece of plastic in order to avoid choking hazards. There are 30 different characters in your army, including the bad guys. Your engineers have come up with 5 different kung fu grips. The designers have come up with 10 different outfits, including different styles of face paint. The weapons designers have come up with 20 different weapons, and each toy soldier could come in any of 15 different positions, so prone, standing, jumping jacks, whatever. That means there are 30 times 5 times 10 times 20 times 15, or 450,000 different combinations. So what do they have to do? They have to choose a few designs and then make 1 million of that single design. With digital fabrication, you can just as easily make 450,000 different toy soldiers, each with a unique pose, weapon, whatever you want. Or you could just make 450,000 of the same toy soldier. I don't know why we would want to do that, but you could. To the machine, it's, like I said, it's all the same file. So it allows you just to customize and have these very unique things that would be tailored to what you want instead of how it's dictated to you by someone else that controls these means of production. Another interesting thing is that you are transformed from a consumer to a producer. If you need a laptop stand, download Eric Skiff's laser cut laptop design and make yourself one. And then you can hold your laptop up on a stand and you don't have to get it from anybody else. If you want to give your friend a copy, you can just make him a copy, or you can sell it if you want. Once you do that, you're no longer someone that just has to depend on other people to make these things for you. You become a producer. You become someone who's self-reliant and can create the own things that you want or need. I'm not an expert on communism, but I think Karl Marx would be happy to see individuals owning and controlling their own means of production without anybody forcing them to have to do something they don't want to do. Another cool implication, and the one I really am pretty psyched about, is that you can open source everything. You can open source the software, you can open source the hardware, and I believe that there's going to be a gigantic proliferation of open source hardware projects once we have this shared platform that you can use to build these things. Because if you make a design and you share it on the internet, other people need to have the same tools that you're using in order to build that design. So once we get to this point where there's some sort of critical mass of people with common machines that all sort of work in the same way, then we're going to see people designing open source robots, they're going to be designing open source machines that do useful things, open source toys, or pretty much anything that you can imagine that could be built by one of these machines. So, who's working on it? I tried to pick people that I thought were representative of sort of the state of art, what's going on right now. There's RepRap, which I like, and they're building an open source, self-copying 3D printer. The entire thing is open source from top to bottom. The designs, the electronics, the mechanical system, the firmware, the software, everything. There's another project called Fab at Home, which is a sort of CNC style machine, and they're also fully open source as well. There's these folks at Lumen Lab, which they released a really nice open source CNC machine. I was looking at it a few weeks ago, and they really did a nice job on it, so it's very good. And then there's also Fab Lab, which is sort of this MIT project where they take all this high-end digital fabrication gear that is usually like squirreled away in like research labs and government offices and big corporations that are willing to pay $100,000 for this equipment. And they just sort of ship them all over the world and hope that people do cool things with them, and which I think is, I really applaud them for doing that. It's a great little project. Or big project, I guess. And there's lots of other people working on this stuff. If you go online, there's a very nice growing open source hardware movement of people building and making and hacking. There are a ton of people working on this. They all have unique approaches, and it's still unclear which one's actually going to come out on top. The dominant project could be sitting in the head of anybody in the audience right now. And I hope so, actually, because if someone in here comes up with that magic idea that just like makes everything click, that would be very excellent. So if you have it, go work on it. I won't be mad if you leave right now. Of course, it's not all like flowers and sunshine. There are some things, there are some problems, but none of them are unsolvable. And everybody's that's involved is working on these things every day. And we need your help. If you know the answer to one of these problems, don't just tell someone about it, demonstrate it, prove it. Take an existing machine or technology, make it better, and show the world how you did it. We will all be richer as a result. So just to break it down a little bit, the first thing that's a problem is the technology is not widespread. It looked like a good number of people have access to CNC machines, which is very, very exciting to me. So the first thing we need to do is get more of these machines into the hands of the hackers of the world that are going to take them and they're going to do cool things with them, and then they're going to get other people excited, and then this thing will just sort of grow very naturally and organically. The second problem I see is there's not really a good shared platform. like I said, there's like 100 different people, and they're all like going in different directions, which is good because from an evolutionary standpoint, eventually someone's going to stumble on the most kick-ass way of doing things, and then everybody else is going to jump on that bandwagon. Third, we really need to get really repeatable results. We need to know that if you print this design 100 times, out of that 100 times, there's not going to be a single error. So it's really just improving the technology, striving for that Six Sigma of very little errors. Fourthly, the costs are still pretty high. I mean, if you want to get a good CNC machine, you're looking at about $1,000, which is amazing considering how years ago it was 10 grand. And the fact that the cost keeps dropping is really exciting and intriguing. I hope that within 10 years, you can get a nice machine for under $100. Just like you can get a nice laptop these days for, $300-400. Also, there's a very large learning curve on the software, the hardware, the electronics. I mean, in order to build one of these machines, you either need to have a very diverse set of competencies, or you need to have a lot of friends that each know a ton of stuff about one area. I would like to see this stuff just become drastically simplified so that you download the program, it sort of can either figure out how your machine works, or it just is very easy to configure. So making the stuff simpler and easy to use will allow more people to get involved. So say you're a 3D modeler. You know all sorts of tips and tricks for using Blender. But if you can't figure out how to get the stepper driver to drive the stepper, then your machine's not going to be able to make anything. So getting that to be a lot simpler and easier to use is going to go a long way towards making this widespread. So how do we get there? First of all, if you're interested in this, get yourself a machine. You can beg, borrow, or steal and get one of these machines and just start working with it. The hands-on experience you're going to get from just messing around with this technology is going to do more for you than any other thing you can do. Just playing around with a CNC machine it's a wonderful experience. Second, and a little bit selfishly, contribute to thingiverse.com. It's an open design site for uploading your open source designs. It does a lot of really cool things that I won't go into, but it's fun. Secondly, if you don't really have a particular machine that you want to get and work with, get a RepRap machine. We're trying to make a machine that will make copies of itself, be able to make new parts for itself. It's totally, absolutely open source. So you can just do whatever you want with this thing. You can build 1 million of them and sell them to everybody else. And if you do that, I'll high five you. Let your friends know about it. If you have friends that are interested in technology or hacking or just interesting things to do, saying, hey, let's build a machine that builds machines and build machines. That'd be fun. And finally, learn as much as you can. If you have a brain, stuff more stuff into it. And I don't think anybody's brain has ever exploded from too much knowledge. So you could be the first. So, in summary, digital fabrication is a real technology. It's coming to a house near you, and you should work smarter and not harder. When the mainframe computer came out of the realm of research laboratories, military compounds, and corporate centers into the hands of normal, average human beings, there was an explosion of software available and innovation. Putting advanced technology into the hands of creative individuals will have surprising and most excellent results. Who could have predicted Google, Amazon, Facebook, SourceForge, or YouTube? Would these things have been created if one needed an expensive budget to purchase a mainframe computer? I find that unlikely. Thank you for listening to my crazy ideas. If you want to go on the internet and get involved or check things out or like find out why I'm so crazy, here are some good places to go. There's places where you can share designs, there's places where you can find out about the technology, and then there's places where you can talk with other people that are interested in it. Yeah, questions? This is the fun part.
Hi. So I don't know anything about this, so I'm looking forward to be educated here. First question, is there anything that looks like a sort of like a universal markup language that's agnostic, that's kind of like architecture or, you know, machine agnostic? So like, you know, something that says, you know, like, in this coordinate system, you know, a physical, you know, markup of whatever it is that you're trying to build, and then some sort of material specification. That's one question.
So this is definitely something that's being actively developed. You can sort of break it down into two different categories. There's 2D design files, and then there's 3D design files. So with things like laser cutters or water jet cutters or things that it's just like a beam that cuts material, it's all vector art, which is really, really, really easy to get into. There's really nice open source programs for doing these designs like QCAD and Inkscape, and there's also really nice commercial programs like Adobe Illustrator is amazing. You know, obviously it costs money, but you can just design these things in normal programs. For the 3D side of things, basically you create a 3D model, and then you run that 3D model through some sort of slice and dice program that says, okay, this is a 3D model. What do we need to do to translate that into a machine-specific thing? So,
I mean, so really for some sort of markup language, it really just needs to say, in coordinate system X, you know, do Y. I mean, I'm surprised. I'm just a little surprised that doesn't exist.
It does exist, but it's more machine specific. Like there's no like overarching one type of language. There's something called G-code, which is what the vast majority of CNC machines do, but that's like go X to Y to Z. And so the generator that generates that code needs to know information about your machine in particular. So it needs to know how big the drill bit is on your machine and so on and so forth.
Hi. You said that your toy soldier manufacturer needs to make 1 million of them to get the economies of scale so that it's economical to do so. Do you envision producing them, each one different, using this kind of technology to ever become as cheap as the mass production we currently have? And if not, do you think the added value is going to be worth it?
You know, I mean, it probably is never going to be cheaper to have a machine go piece by piece and build up a toy armament than it is to have a giant machine that'll stamp out 500 of them in one go. But the thing is that I feel that people will value the ability to customize and build the things that they want more than being able to just get one of something. The other thing is, I didn't really get into it during the talk, but by revolution, I don't mean that this is going to completely replace the existing system. Open source has been completely revolutionary in the world of software, but there's still Microsoft. There are still tons of people out there that are selling software, and I think that's excellent because these things can coexist. There's a reason for all of them to be there. So with the toy soldier example, it's great to be able to just mass produce something because the design's already excellent and it's cheaper to do it that way. But also being able to control the design yourself and make modifications is very valuable. So I plead both.
Can you show us a few examples of things you did? So I'd really like to see something like that.
So I guess I can go on Thingiverse here. The other day we had this thing called the Laser Battle 2008. And so basically we set up these rules for this contest. You had to use 12 inches by 12 inches, 308 millimeters by 308 millimeters of whatever material you want and laser cut something out of it. So I decided that, oh no, I don't have internet here. So I decided I wanted to make a pump out of it. So I make a pump that fits onto 12 by 12 inches of quarter-inch acrylic. You laser cut it out, you bolt it together, you put a little bit of tubing in there, and then you have a working pump that can pump whatever you want. So I'm going to use that to build a drink serving robot. But the idea is that you could just download it and make something. In the way back? Or the front? That's easier.
I'd like to know if you've thought about the ecological implications of this. I mean, if it's going to be all over the world and everyone producing whatever they want to produce, how is it going to be ecologically sustainable?
Well, I mean, for one thing, you won't have to. Let me rephrase the question. I think he asked how it's going to be economically sustainable if... Oh, ecologically. Well, first of all, this is both economic and ecologic. You won't really have to pay for shipping all of the finished goods from point A to point B. So there'll be a lot less traffic on the roads of shipping things around. You will still have to ship the raw materials, but instead of shipping the raw materials from wherever they're created to a factory and then building these things and then shipping them on to the end point, the raw materials will just go straight from where they're built to where they're needed. Secondly, what we're trying to do is with at least RepRap, it's a thermoplastic, so theoretically you should be able to grind it up, remelt it, and build new things. So if we create open source recyclers, you will be throwing out less stuff because you'll be able to reuse the things that aren't useful anymore.
Hello. I'm wondering about the limitations regarding form and materials. I think there's only so much you can do with a laser cutter or a 3D printer. Maybe I'm lacking imaginations. Are there any new technologies on the horizon, or what are your ideas?
The thing about this is that there's not really any new technologies out here. The powerful thing is taking these existing technologies that are already used to do a huge amount of things, but putting them in the hands of average, ordinary people that can then think up new and exciting things to do with them and then use them for their specific purposes. I mean, there's a wide variety of different things that you can do with a laser cutter or a 3D printer. And it's really up to your imagination to figure out what to do with them.
Can you give some numbers, how much time and money it would take me to build such a RepRap for making tin soldiers, plastic soldiers, and how long such a machine takes for making one small thing?
So right now, I think just like a ballpark figure to build a RepRap machine, you're probably looking at around $750. Sorry. But it's really a time versus money trade-off. If you have a lot of time but not a lot of money, then you can cut corners and save money. But if you don't have a lot of time and you have a lot of money, there's a lot of high-end stuff here that you can buy that is just going to bolt together and work, and you'll be able to just get started right away.
Hello. Is there existing license for open source objects? Because someone can make a patent on it and earn money up.
That's a very good question, and I don't really think there's a good answer for that yet. I've chatted with a few of the lawyers from the Software Freedom Foundation, and basically the thing that they told me was that These designs are theoretically covered under copyright because it's not an actual item, but it's a design for an item. So there is definitely still the possibility of patents being involved because it's not software, it's actual real physical things which patents were designed to cover. So I then asked him, I was like, well, what's the best defense to protect ourselves from someone maliciously coming in and saying, oh, you can't build that thing that you worked hours on because we own the patent for it. So he said that if you have an idea and you want to protect it from patents, you should write about that idea and establish that you have come up with that idea. Because then if someone at a later date tries to say, oh, we thought about that, the idea is to have this prior art that you can say, no, we've been doing this, we thought about that. You don't actually have to make something, you just have to write about the idea of making something. And that establishes that the idea is already there and that it's been discussed in the world. Can't hear you.
Sorry. One thing I wanted to point out is that I think from an economic point of view, the value of what's going on with the digital fabrication is a revaluing of our individual labor. Because rather than having a kind of division of labor in a factory setting, so the way that Adam Smith was so proud of how, you could set up a factory and have people just, make cogs. So one person makes a gear over and over and over again, and that's the thing they do for their entire lifetime. And they never actually get to see the finished product. So Marx then 160 years ago knew that that led to alienation in workers. So what you're describing and what part of the revolution you're describing is that we as individuals can go from the idea in our heads all the way to the finished product. And we can be involved at every single step from that creative impulse to creating the machine that is going to make the object, all the parts of the object, to putting it all together, to then using it, and then maybe even recycling it with our open source recycling gadget in the end. And I think that's incredibly valuable, and I kind of wanted to point that out to the group.
Thanks.
Maybe I have an answer to the patent issue. As being an inventor, I was faced to this question, and well, I can say something to the law in Germany. It's actually impossible to the law says you cannot get a patent on something which was published before you went to the patent authority. So actually in my case I wanted to get sure, and I just went to the patent office, and there's something like a patent light in Germany, it's called Gebrauchsmuster, and I just went there and I I gave them my Gebrauchsmuster, paid my 40 euro, and so I got officially documented that I had this idea in this moment.
Excellent. I'm not sure that was a question, but that's okay. So it sounds like if you have an idea and you want to protect it from someone stealing it, but not want to protect it from other people using it, then your best bet is to share it with the world as soon as possible. And then nobody else will be able to come along later and say, we had this idea first, you can't use it. Anybody else have a question? Raise your hand.
How you doing? I was just wondering, do you have any vision for a commercial aspect to these designs? Will companies be able to produce designs and sell them so that people can make them at home with their own customizations? Or in the toy soldier example, could they sell the design to all the different components and the customer then build their own package from it?
Personally, at the RepRap project, we hope that people will take our design and sell it, because just due to the nature of the open source license and the project itself, if they're going to take it and mass produce it, they're going to need to make adaptations and improvements to the design. And since they're required to release those back to the community, it's going to make the project as a whole much better. What we're focused on is we want to make this technology really awesome. And so if someone can make it awesome and also make a living for themselves at the same time, I applaud that. So, yeah.
So there was one more person down here. Oh.
So is anybody doing sex toys with it yet?
I'm surprised Rose didn't ask that. As far as I know, I'm not sure. I don't think so, but you know, theoretically you could. Okay, I guess we're done. Thanks for your questions.